Is it recording? So just so I can document this, my question was, I've got 3 scenarios here. I've explained the model of friction, that friction is less than or equal to mu r, where b is the coefficient of friction and r is a normal reaction. I use the bag to explain that if you've got loads of books in the bag, that's going to increase the value of r because of the fact that the mass going down will increase and the weight will increase because weight is equal to mg. So that's the r component. And the friction, coefficient of friction is the contact point's roughness. The roughness is because of the fabric and also the surface. So that's what the mu is representing, coefficient of friction. So now my question to the whole class. The whole class is this. In the first case where I've got 10 Newton force going to the right, and I've got 50 Newton force of friction on the left, opposing. And my question is, which way is this moving? And I would like everyone in one go to say either left or not moving or right. So in 3, 2, 1.
Left.
Okay, who said not moving? 1, 2, 3 people. Who said left? Okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 people. Okay, said left. Who said right? No one said right. So the majority of the class said that this is moving to the left. Okay, now if I had more time, I would unpick and I would ask why people said what they said. But we don't have enough time. So watch this as an example. Okay, here's my bag. Here's my bag. Okay, so watch this. I've got books in this bag. I could put loads of books in here. Okay, listen up, listen carefully. I'm pulling this 10 newtons this way. I'm pulling it 10 newtons this way, okay? There's a force of 50 newtons of friction available that way. Now, I'm pulling it 10 newtons like anything. There's a mu there as well at the contact point. Okay, what's happening to the bag? It's not moving. So why did the majority of the class say it's going to move to the right? Well, my right, your left. What do you get? Can you say louder so you can actually have your voice? Don't put any student there, but you just your voice. Yeah, what does it say?
The friction is stopping it from moving.
Okay, so this is now you changed your opinion, yes? Okay, Jaden, you had the opinion of it not moving in the first place. So why did he say it's not moving?
Because it's friction.
What do you mean by that?
It's friction. It's not something. It's not a force that moves. It's a force that stops.
Can friction move something? No! It can't move anything. It just stops movement. How much friction? Who else said no, just have interest? Okay, so how much friction is being used to stop this from being moved? How much friction is being used to stop that being moved? Think about it.
40.
This one, how much friction is being used? 40. Okay, what's your response? 10. Why 10? There's only a force of 10 going this way. So how much force do you need it to stop from moving? 10. So what does this represent, the 50 newtons? It represents what force? It's friction. It's the... What does this mean? What does a less than or equal to mean?
Less than or equals to the force.
Yeah, but what does it mean? You're nearly there. The pip's gone, but let me just finish off.
It'll be the same.
No, but just imagine. Okay, this is 50 newtons. Okay, our friction is less than or equal to 50 newtons. How much of this is needed to stop it from moving? 10. For why 50? I've only got 10 by that way, isn't it?
Yeah.
So in this case, how much is needed is 50. How much? And what's happening in this case? It's moving to the right. So what does this mean? Less than or equal to?
How much is not going to move less than equal?
But if it's less than there's going the force like it's going to the
Should I?
If it's not less than or equal to the force, the pulling force, then it won't move, or it will move.
Anyone else? This represents the maximum potential friction available. It doesn't mean you need the maximum potential available. Less than or equal to means that for it not to move, whatever you need for it not to move, that's what you need. Are you with me? It's a resistive force. One more final point. In this scenario and this scenario, you are at F max. F max equals mu r, and F max in this scenario is 50. And that's what the maximum potential friction is, which is called limiting equilibrium, which is what we're going to be doing next lesson. What do you think? I got a round of applause in my last lesson. Thank you. So it's in the last lesson, everyone thought it's moving to the left. I understand why I didn't get a round of applause this time, because 3 people figured it out. So well done.